Hello, this is Mitra, co-founder of STEM and Space, an educational institute based in India. Today, I will be talking to you about astronomy and space as a gateway to teach STEM in India. Now, let's talk about factors relevant to India. It is a large and diverse population, diverse in languages, in economic structure. So it is very important to find the right educational mode that will appeal to people all across the country. As an old country, India still has superstitions and astrology. In fact, many people believe that eclipses are inauspicious, and some even believe that it was demons swallowing the sun and moon that caused eclipses. Astronomy and astrology are historically present in culture, literature, and architecture. Given this scenario, it is very important that scientific temperament be inculcated and nurtured. Education in India. Education is important, but it is also very competitive, and it is the prime objective of science education is to get very good jobs, to create the career pathway for very good and lucrative jobs. So students are in general not interested in science education. They find it boring and dry, but it is still the one objective to get good jobs. So what do we have to bring into the system? We need to train students to think rationally. We need to make them understand that STEM will be the careers of the future, and they should start enjoying it and develop investigative learning. What is the current scenario of astronomy education in India? There is no astronomy at the school level. Mostly, it is only present at the postgraduate level. So, how do we approach it? Through activities or extracurricular. That's the way to take it to schools. Recognizing the importance of astronomy education, the government has introduced Tinker Labs and astronomy as part of those labs. And also, our space center, ISRO, has initiated a program called Space Tutors to disseminate space education. Now, space as a subject appeals to students, whereas curriculum, direct curriculum, appeals to schools and teachers. So we need to find a strategy that connects space to subjects that are curriculum based. Why do students find astronomy exciting? Students are fascinated by astronomy. It's in social media and movies all around you, including when a web released its first images, you might have seen that everybody was posting it on social media. So it has caught on as a popular subject among amateur astronomers and among students. You can observe it all around you. Whereas students find science boring in schools, and many of them give it up in high schools, most students love space. So, education can take advantage of this natural curiosity to develop skills towards STEM and to attract more and more young people towards STEM. So, what is STEM? Science, technology, engineering, math. But it's not just that, it's a concept which makes it interdisciplinary and tied into real world applications. Now, astronomy and space are linked to many phenomena and current problems all around you, such as seasons, sunrise, sunset, moon phases, navigation, climate change, and biological evolution. Space is a great tool to take forward STEM because there are so many real world scenarios that you can bring forward, and it is interdisciplinary. From space topics, you can directly relate it to our own world. Space is easy to correlate to STEM curriculum topics. So you can relate it directly to topics like physics and math, which are, of course, the foundation for astronomy, and indirectly to topics such as astrobiology, chemistry, climate, geography, engineering, and even skill building topics such as programming and data analysis, robotics, rocketry, photography, and so on. I would like to talk to you about STEM and Space, the institute that I represent. It is a niche educational institute. Our objective is to integrate STEM learning with space science and astronomy. So with that objective, we are trying to create sessions to attract students and schools. What kind of sessions do we create? Our approaches to make innovative sessions that are hands-on and experiential so that students don't just sit and listen, they can also learn by doing. So we have workshops, space clubs, and projects. So at STEM and Space, our objective is to create innovative ways to connect space to STEM curriculum. Let me talk about a few ways and a few kind of sessions we are doing this with. These are some examples. Like I said, physics is one of the basic foundations. Through learning about light and spectra from stars, by spectra from stars, they learn about the composition of the stars and how different emission and absorption lines represent different elements. Through sundials, the ancient way of timekeeping, students can learn about sun and its movements, about shadows, and through the celestial coordinates, they can also understand about geographical coordinates. Now we go on to more indirect topics. Through astrobiology, which is very exciting, they can learn about what is life, why is Earth the only planet we know that is habitable? Is there life anywhere in our solar system, and where do we look for it? Which planets? Which moons? Is it outside the solar system? Here I show a very interesting map that we have. It's called the Giant Moon and Mars map. We have it courtesy of ShareSpace and Aldrin Foundation. Through these giant maps where students can sit, they can surround and walk on it, they learn about Mars and Moon features. They can compare them to Earth features, and they learn about topography. Some engineering topics, students learn about parachutes and landers, especially young students love this kind of activity. Students learn about structures like truss, which are weight-bearing, which shapes make it more weight-bearing. Here is a student with a model. Students also make satellite models and learn all about satellites, such as their components, what satellites, what is their functionality, what are their applications. Geography and earth sciences, by mapping volcanoes, different layers of volcanoes, they understand about age of different layers. Through landscape mapping on different planets, they can convert the topography to contour maps. Data analysis and coding, there's fun ways to teach that. Here is a Hohmann orbit, and we teach students to use tools such as Scratch to replicate the same kind of Hohmann orbit. And through that, they understand coding concepts and the flow and syntax. Satellite images don't come in real color. Astronomers use false coloring using histograms to visually represent images. Asteroid Search Campaign is an international citizen science program also that we bring about. With that, I would like to summarize that astronomy and space are very important to include in the education system. They are a gateway to conventional curriculum as well as modern subjects, and STEM and space are trying to introduce it into schools in India with innovative methods and activities. I thank the Shaw-IAU Workshop for giving me this opportunity.